Hey everyone, today we are going to solve this really interesting problem. And once you solve this problem, you will see how elegant mathematics can really be. So, this problem is something that really made me fall in love with maths one more time. And I already love it, but this question kind of reinforced that emotion. Okay, so what is the problem? The question is we have two squares, the blue one and the orange one. Size of the blue square is given to us. Its sides are 4 units in length. And we have to find out the area of triangle ABC. And triangle ABC I have marked here. Triangle ABC is formed by joining three vertices, the two opposite vertices of the first square and one vertex from the second square. So this is what we have to calculate, area of triangle ABC. In the first look, it appears to be a general geometry problem, but the beauty of this question lies on the fact that we don't know anything about the second square. And that implies that area of triangle ABC is invariant invariant with respect to the size of the second square. We don't know what is the size of the second square. And that directly implies that irrespective of the size of the second square, our area of triangle ABC is going to be same. That implies area of triangle ABC is invariant in the sense it doesn't vary with respect to the size of the second square. And this idea is going to be super useful in solving this question. Right. So let's extend this idea. If the size of the second square doesn't matter, I can take second square as larger than the first square or smaller than the first square as shown in the second figure. Right. If I take the second square as the green one, then also area of triangle shall remain same. The only thing that changes with the size of the second square is that the dimensions of the triangle ABC change. So the sides AC and BC in the first figure and sides AC and BC in the second figure are different. But our question is saying that area of triangle ABC should be same. The question directly did not say it, but we have inferred it from the fact that the answer is going to be independent of the size of the second square. Really amazing idea. So there are two ways of solving this question, and I will start with solution that made me really fall in love with this question. The solution is very simple. If you have already got the idea, the size of the second square doesn't matter. So you can take size of the second square anything that is convenient to you. So what I am going to do is I am going to choose the side of second square such that it is exactly same as the first square. Let me mark this point as D. So what I'm saying is let's take the second square congruent to the first square. And this won't change the value of area because we have already established that size of second square really doesn't matter as far as value of area is concerned. And once we have established that, and once we have chosen the side of the second square as same as the first square, the area is going to be super easy to evaluate. Area of triangle ABC equals to half of, let's say that AC is the base of this triangle. And if AC is the base, we can very easily see that BD is going to be the altitude. So the area is half base multiplied by altitude. And since both these lengths are, we have taken as 4, so the area is coming out to be 8 square units. How amazing. And this is not the end of the amazing part of this question. Let me extend the idea further. I'm saying that the size of second square can be absolutely anything. So what if I reduce the size of the second square? I reduce the size of the second square such that the length of side of second square approaches to 0. What will happen then? Let's see. Something like this. Now we are talking about the edge cases. Edge cases where we are testing the limit of our idea that size of second square can be absolutely anything. So what I'm going to do here, I'm going to take the size of second square as approaching to 0. And we can see if the second square size approaches to 0, the problem becomes even more simpler to evaluate. The area of triangle ABC will be approximately equal to half of 4 into 4. Half of 4 into 4, that is 8 square units. Why I'm saying approximately? Because size is only approaching to 0, and when we calculate the limit size approaching to 0, the area is not going to be approximately 8, it's going to be exactly equal to the 8. But I'm not going into the concept of limit, that is a separate chapter. We will talk about it in some other video. But this is a beautiful concept. You can take the size of second square as 0, and area is super easy to calculate. It's coming out to be again 8 units. And there is one more edge case that you have to try at home. I'm not going to discuss in this video. That is again very interesting. What if the size of second square is, instead of very small, I take the second square as very large compared to the first square? So what I'm trying to say, what if x approaches to infinity? What will happen to the area of triangle ABC? Area of triangle ABC as x approaches to infinity. This is something that you have to try evaluating. And I assure you the area is again going to be 8, because we have already established this fact that area is invariant with respect to the size of the second square. So this was very interesting, especially the edge cases where the size of second square can be 0 or infinity. Infinity one, you have to solve it, apply your mind, and let's see what you can do here. So this was method one. There is one more way of solving it, and that basically that method comes in handy if this idea doesn't strike you. If you don't get the idea that I can take the size of the square as 0 or size of the second square as 4 units, then you can use simple algebra to solve this question. And let's see what we are going to do here. We will say that since we have to evaluate this area triangle ABC, let's say that the size of second square is x units, and size of this common side is, let's say, y units. So this will be 4 minus y. We can mark some points. Let's call this point as D, this point as E, and this point as F. So I can say that the area of triangle ABC is sum of the areas delta 1 and delta 2. Delta 1 is the blue area here, and delta 2 is the orange area. And in this method we are going to use simple algebra, no fancy concepts here. How can we calculate delta 1 and delta 2? Again, very easy to calculate. Delta 1 is the area of the blue triangle, and area of blue triangle is very easy to calculate if you appreciate this basic idea that if the base of this triangle is AD, then its altitude is going to be BE. So area of triangle delta 1 is coming out to be half of the base AD multiplied by the altitude BE. And we can substitute these values. Half of AD is y units, we don't know the value of y, and BE is 4 units because BE is the side of the first square. So this area is coming out to be half of 4y. Similarly, we can find out second area delta 2. Delta 2 will be half of this base, which is y, and this altitude, which is x. So delta 2 is half of y multiplied by x. And when we add these two areas, we will get area of triangle ABC. But this time, this area is going to be in terms of x and y. Something like this. So the area of triangle ABC is coming out to be in terms of x and y, and somehow we have to find a relation in x and y so that we can find out this area in terms of number, which is going to be 8 square units that we have seen earlier. So let's see what we can do to find out another relation between x and y. What I'm going to do here is that we are going to use similarity of triangles. We can see from this diagram that triangle BDE, this triangle, this one, triangle BDE is similar to the triangle, the big triangle BCF. Triangle BDE is similar to the bigger triangle BCF, and maybe I can use some different color to emphasize that. This is the big triangle BCF, right? So these two triangles are going to be similar, or we can very easily see why they are similar. Both are right angle triangles and both have this common angles, right? This angle is common to both triangles. All right, so these two triangles are similar, and that implies that the ratio of corresponding sides of these triangles are going to be same. So I can say that ratio BE and ED, let me write it here, BE over ED is going to be same as BF over FC. And we are going to use this concept. So we have ratio of these two sides BE divided by ED. So BE is 4 units and ED is, I think, 4 minus Y. This is coming out to be equal to BF divided by FC. The value of BF is going to be 4 plus X. So this is 4 plus X divided by X. And we can solve this equation very easily. Cross multiply the terms. We will get 4X equals to 16 plus 4X minus 4Y minus X multiplied by Y. We are simply cross multiplying the terms, cancel out some terms, and we will get 4Y plus XY equals to 16, or in other words, Y times 4 plus X is coming out to be 16 units. And we can substitute this value here to find out the area of triangle ABC. So again, area is going to be area of triangle ABC equals to half of Y multiplied by 4 plus X. Y multiplied by 4 plus X is coming out to be 16 units. So this is half of 16 units, that is 8 square units, as we calculated in the first method also. So this was really amazing problem, and I want all of you to understand the first method that we see. That was really beautiful, and I hope you guys liked it. If you did, do not forget to like the video and share the video with your friends. Thank you very much. Have fun. Take care.